A young man walks into a hospital room carrying a standard steel oxygen cylinder. Before he can react, an invisible force yanks the heavy metal tank across the room and slams it into the white medical tunnel. The young man died on the spot from the impact. To understand the strength involved here, consider an industrial junkyard crane. Those magnets use about 1 Tesla of power to lift entire cars. This machine is often 3 times more powerful. These warning signs and physical barriers guard a room containing one of our most effective diagnostic tools. It provides detailed internal images with 0 harmful radiation, but only if you respect its physical environment. Understanding how we turned such a lethal force into a precision medical tool requires looking at the very atoms that make up our bodies. The foundation of this technology is a simple biological baseline. The human body is roughly 60% water. Most medical imaging works like a camera, taking a picture of what is already there. But an MRI machine doesn't take a photo of the water in your brain or muscles. Instead, the machine applies external forces that pressure the water molecules inside your organs to actively broadcast their own location. The real challenge is manipulating these invisible forces so that a living body is essentially forced to draw a map of itself. Inside the dense metallic rings of the machine sits a coil made of niobium titanium. It is submerged in liquid helium and chilled to -261 degrees Celsius. At this extreme temperature, the wire reaches a state of superconductivity, meaning it has 0 electrical resistance. Because there is no resistance to stop the flow of electricity, once this superconducting coil is fully charged, it creates a massive permanent magnetic field that stays on for the life of the machine. Inside your body, hydrogen atoms in your water molecules are naturally chaotic, spinning in every possible direction. The moment you enter the bore of the scanner, that massive magnetic field overwhelms those atoms and locks them into a uniform line, pointing in the same direction. While the atoms are now disciplined, they are also silent. To get any data, the machine has to find a way to make them talk. This is where the radio frequency coil comes in. Placed near a specific area, like the head, it fires a targeted pulse of radio energy at the patient. This burst of energy knocks the hydrogen atoms 90 degrees out of alignment. When the pulse stops, the magnet pulls them back into formation. As they snap back, they release energy as a signal. The specific frequency released is dictated by the magnetic field's strength. This signal is the diagnostic key. Healthy tissue and abnormalities, like a blood clot, contain different amounts of water and will release their energy echoes at different speeds. The machine can now hear that a problem exists based on these echoes, but it still doesn't know where in the 3-dimensional space of the brain that signal is coming from. To pinpoint the location, the machine uses gradient coils. These are designed to intentionally make the main magnetic field slightly stronger or weaker in specific areas. These coils create a predictable grid of magnetic variation along the X, Y, and Z axes. This creates a magnetic coordinate system. Because each grid point has a different magnetic strength, a value like 1.2 Tesla corresponds to one single point in space. Remember that the frequency an atom releases is tied to the magnetic strength it feels. By identifying the exact frequency of the echo, the machine can work backward to find the 3D coordinate where that specific magnetic strength exists. By matching these frequency echoes to their corresponding magnetic strengths, the machine finally assigns a physical location to every signal it receives. By plotting millions of these individual coordinates, the MRI generates these high-contrast images of the brain's internal structures, showing us detail that was once invisible. Ultimately, the machine functions as a mathematical translator, turning the echoes of water molecules into a visual map. But we must return to the opening warning. Because the superconducting coils require a permanent state of extreme cold to function, that lethal main magnet is always on. This is why total honesty about past surgeries or metal implants is a requirement for survival. The same field used to map your brain will violently attract any iron-based object nearby. The MRI succeeds not by looking at the body from the outside, but by using the hydrogen atoms already inside of you to broadcast a map from the inside out.